Good evening to all of you. This is Akash Sharma, and I welcome you on behalf of Midas IT to the second webinar on integrated 3D platform for pile-raft foundation analysis using GTS NX. So today our main focus is basically how to take a building from Midas Gen and along with the loads, and then how to create the continuum model in GTS NX. And for today's case, we will just try to analyze that what is the effect of the pile-raft foundation, combined pile-raft foundation when you use it. And for the same case, if you are just using raft. So basically we'll compare and we'll see the advantage of combined pile-raft foundation and how basically we can optimize it. Okay, so today basically we'll just see the workflow of completing the whole process. So as you can see on the screen right now, you have a Midas Gen model. Okay, so with all the materials defined, okay, and all the properties, the section, everything, you can just see it from Midas Gen. So for those who are unaware, Midas Gen is a product of Midas software solution, which can be used to analyze and design all types of building and general structures. Correct. So what we are going to do here is we are going to take this building along with the loads, okay, along with the dead loads and the live loads into GTS NX directly to perform the soil structure interaction. Okay, so how basically this gen will be useful to us, okay, is basically we need two things from here. Okay, first is the whole model, okay, along with the dead loads and the live loads, and secondly we want the AutoDXF file. Why the AutoDXF file? Because right now you can see at the building, let's suppose for this case, we have provided a fixed boundary condition at the bottom, okay, but what we need to do is we need to create a continuum model of raft and soil below it. Okay, so we want to make sure that each of this column is having a node with the raft. Okay, what I mean to say is, as you know, in finite element analysis, load and stresses transfer takes place from node to node, correct? Now when we bring the building from Gen, the first thing we should make ensure that each of the column is sharing a node with our substructure modeling, which will be starting in GTS NX. Okay, so just to conclude, we need two files from here. One we call it as MXT file. MXT file is a format which takes Midas Gen file to GTS NX, and the second thing which we need is the AutoDXF file. Okay, both we can get through Gen quite easily. Okay, so let us proceed and see how exactly we can do. So this is the Gen model. You go to Gen, you say export. So you can see there you have a file called MXT file for FEA GTS NX. Just click on that. Okay, and I'm just going and creating a new folder and save it. Okay, so the program will automatically export this file, export this MXT file, which you can directly import in GTS NX. The second thing which we required from here is you go to export and you go to AutoCAD DXF file and just say export, and you can save it in the same folder, or it means wherever your project folder, you can keep it over there. Say save. Clear? So from Gen we have taken two files. One is the AutoDXF file and the other is the MXT file. I'm closing it. So this is GTS NX. So this will be what we are going to model today. So let me just show you step by step how we will be proceeding for the same. So I'm saying file new for a new project. Say OK. Okay. Now first thing what you need to do is you have to import the building, the MXT file which you have created. To import, you go to GTS NX, import, and Midas MXT. Okay, just click on that. Select the file which you have exported and just say open. Okay, so the whole file will be imported with the dead loads with the and with the live loads. Now let us see what comes along with this MXT file. Okay, so let us check. You can check everything from the left hand side in the workstree window. So all the materials which has been defined, all the property. Okay, now these are basically the sections. So if you want to see how exactly the sections looks like, okay, I'll just hide the load for you, just a second. Okay, and in the mesh, you have to just make sure that it comes as a default mesh, walls, links, and beam. Okay, so to make it all a one set, because I will be using it as a load, I am just dragging and drop all of this to the default mesh set. Say okay. Okay, now the whole mesh set, the default mesh set represents my building. Okay, if I hide, I can show you that this is my building. So please remember that. Now default mesh set represents our building. Okay, now till meshing, everything on the left hand side workstree window you can see here. Then you go to analysis. So in the boundary condition, the fixed boundary condition at the bottom, okay, and all the loads, okay, have come up over here. Okay, so wind loads and the earthquake loads cannot be imported, so I'm just deleting it. If you want to do it, you have to import it as a static force, or after bringing here, you can apply the wind load as a static force. For dynamic, you can generate the dynamic load here, and it will be applied at the bottom of your model. Fine. So these are the two loads. Now few adjustments which I would like to do is, whenever you bring anything from gen, the dead load, the gravity is defined in the dead load. Okay, now we don't want to keep it in dead load along with the other sets, because in the initial stages we would like to initialize the stress condition in the soil because of the self weight. Okay, so what I'm doing is I'm just deleting it from the dead load. Okay, and then you can come in static slope analysis and define a self-weight mesh load set separately. You'll understand why when I will show, or when I will demonstrate you about the construction stage. Okay, so now we have self-weight, live load, and dead load. Okay, so this is my building imported. Okay, now how to make sure that whether it is correct or everything has been properly imported or not, or all the loads has been considered or not. Okay, so what you can do is, with this model you can just run a simple linear static analysis and check for the reactions. Okay, so you can go to analysis, you can go to general. So here you will a simple linear static analysis. So I'm moving everything on the right hand side to have them considered in the analysis. Okay, so whatever you activate goes here. So if you just want to check for dead load, you can just activate the dead load, similarly live load and self load. So I'm moving everything on the right hand side and I'm giving it a name, LS, standing for linear static. Just say okay and perform the analysis. Say okay. Okay, you can save this file. I can just name it as 2. So you have to run this analysis. This step is basically to make sure that both the model which we have been imported is basically imported along with all the dead loads and live loads correctly. Okay, so that we can proceed with the further modeling in GTS NX. So I'm just waiting for the analysis to perform so that I can show you how exactly to extract the results. Okay. Okay, so the analysis has completed. Fine. So as you can see, now the analysis has completed without any warnings. Okay, so to see the results, you can come in the results. You can go to linear static. You can go to displacement, everything. But what we are interested in reaction. So TZ. I'm just making it undeformed so that we can see it clearly. Okay. So what we can do is now we can take this nodes. Okay. So you can go to extract. So you can go to reactions. Okay, so we are interested only in TZ. Okay, select this bottom nodes. Okay, and just say table. Okay, so you get this table forces. You can take it to Excel and just check for the summation whether it's equal to what you have in Midas Gen or not. Okay, so I've already done this for you just to save some time. Okay, so as you can see, this is the Gen file basically. So the total load, including the dead load and live load, is 617,550 kilonewton, and same after extracting the results, we have the same value as we got from GTS NX. Fine. So what does this implies that all the dead loads and the live loads has correctly been imported, and now we can create basically our continuum model below this building. Okay. So I'm going to pre-mode again. Fine. So now let us go to modeling, because till now we have not done anything in GTS NX except for modeling. Second thing, we have to import the DXF file. So I'm just going to import DXF 3D wireframe. Select the DXF file. Just this is the DXF file which I exported. So open. So what happens exactly at the same location, you will find that the DXF file has been imported. Just say OK. Fine. So just to show you, I will just now close this. If I hide the default mesh sheet, so you can see all the curves which has been imported. Okay. Now why we need is basically we need this to imprint this columns onto our raft. Okay. So we'll see how exactly we can do that. So for now, I'm keeping the geometry as well hidden, just activating the default mesh sheet so that I can show you. Okay. Now I'm showing show all guiders to show you the various work planes. Okay. Now, first of all, I am changing the work plane to XY as per the global coordinate system. Okay, so that I can create my profile in the XY plane. Okay, so first of all, I'm using a rectangle. Okay, so this is just an approximate rectangular. I'm using a rectangle for my raft generation. Okay, so let us input the coordinates. Okay, so I have already calculated the coordinates as per for this building. So it is minus 5.7 comma minus 5.1 and relative 48 comma 40. I'm sorry, just I need to change the unit to meter. Okay, so Control Z, it all took millimeters, so we're not able to see it. Okay, so I'm saying rectangle. Anytime you can change the unit system from here. Okay, from the right bottom corner. So minus 5.7 comma minus 5.1, enter, and then 48 comma 40. These are the units in meter. Fine. So this is just for demonstration purpose. I have just created, you know that this couldn't be this much close. Okay, so I'm just taking this for a demonstration, so you can increase the size as well. Okay, then this is basically the dimension of my raft. Then we have to create the outer soil profile. Okay, so I'm just using a rectangle again to create the same. So the initial corners being minus 60 comma minus 60 and the relative being 160 comma 160. Fine. So the inner rectangle represents my raft and the outer rectangle will be representing my soil mass. Okay, now people are very reluctant to move to 3D because of the complexity of the modeling. So I will show you how exactly or how easy it is to model any complex problem in GTS NX. So anytime you deal with any problem, the best thing which you can do to avoid complexities is just think of the best 2D simulation of your problem. Okay, so for example, in this, what I need is I need a rectangle, I need a rectangle for my raft, and I need a rectangle for my outer soil. Then to create a profile out of this, or to create a solid out of this 2D profile, we need the command called extrude. Come to extrude. Okay, select the target object. So whenever you go to select this rectangle, at time you will find it difficult because it is controlled by the selection filter. Okay, so you can change it to basic. You can easily select this rectangle. Select the direction. So this is the direction in which you want to extrude. Okay, now let's say the length is -2, that is in the negative direction. You can preview it every time to check whether it is going in the correct direction or not. So if I go to the front view, I can show you that it's correct. So negative -2 is basically the length, and you can make it a geometry set, a set of raft. Say apply. Okay, so the raft is now created. Now select the target object, again make it basic. Okay, now select the outer soil profile. Okay, so I'm considering 4 layers of soil in this particular model. Okay, now let's suppose the first depth is -5. Okay, there are various methods of approach. So today I'm keeping it simple just by using extrude command. Okay, so geometry set layer 1, say apply. Okay, now next layer thickness is 20 meters. So what you can do is you can rotate it. Okay, by pressing the scroll of your mouse, you can just rotate it. Select the target object. The selection filter reads face, so you can select this face. Okay, select the direction. So again, I can directly select the vertical axis, and then the length is, let's say, -20 meters. I can give it a name, layer 2. Okay, so preview and say apply. Similarly, you can select the bottom face of the next layer and input the thickness of the next layer, which is -25 and layer 3. Okay, so just using the extrude command basically to create the soil profiles and the raft. Okay, so apply, select target object, select the direction. The bottom layer I am considering a thickness of -15. Now, up to what thickness we should go, or what should be the width of the outer soil model, there are some basic first-hand rules, but what I believe in is after the analysis is run, the settlement contours at the corners or at the bottom edge shouldn't touch the edges or the bottom. What I mean to say is that you should get approximately 0 or nearby 0 displacement at the bottom at the corners. Okay, now there are basic rules like uh, 2 to 3 times B, where being be the area of concern. Okay, but the best part is after you run the analysis, you check the results and make sure that the settlement contours doesn't touch your outer profile. Okay, so different methodologies used for different by different engineers. Okay, so I'm just going to see, and after the analysis I will show you whether it is sufficient or not. Okay, for an approximate I just went almost, it is 25, 50, 65 meters down for this particular model. Okay, so after this, next is basically I'm just hiding the mesh set and I'm activating all the geometry so that the building DXF file which has been imported is also activated. Now the important part here is we have to imprint this column onto the top surface of the raft. Okay, so that when we activate our default mesh sets, the proper transfer of the load takes place from the above mesh set to our raft foundation. Clear? So what I can do is right now I'm just hiding my other layers so that I can show you in focus the raft foundation. Okay, so we have an option called Imprint to do this. Okay, so when you go to geometry and surface and solid, you have the option Imprint. Okay, so what kind of imprint you want to do? So even if you don't have the building, you have the column points, you can use that to imprint. So right now we have the curve. Okay, select the target object. So the target object being the face where you want to imprint it. Okay, now for this particular model, what I'm doing is I'm imprinting this to the top and the bottom face. The reason what I am doing for this model is basically since I have not came up with the pile layout, what I am doing for my initial analysis is I'm selecting the point just below the columns to create my pile. Okay, I will show you how. Okay, so my target objects are the bottom and the top face of the raft. Top face is a must because this column node should be imprinted on the raft for proper stress transfer. Now select the tool objects. Now you have to select all the bottom columns, okay, the base columns basically. So it is never easy to do that. So you can just go to front view, change the selection by select by intersection. Click here and double click on the other side to select all the columns. As simple as that. Okay, so the direction will be direction of shortest path, and you just say OK. So what happens now as a result of Imprint, if I can hide this building for you? So now you can see that there are points created at each of the building locations, at the top and the bottom. The top is a must, okay? The bottom I'm using for this model so that I will extrude this point to create my piles. Clear? Fine. Now after we do that, the next operation we do is we auto connect our solids. So just go to auto connect. Now auto connect is important because right now if you see layer 1, if I hide the raft, layer 1 is a separate solid and raft is a different solid. Okay, so to ensure nodal connectivity, just do auto connect, go to Boolean, say select all and say OK. Fine. So now if I hide the raft, you can see that it has been cut out of the main solid. Okay, and even the imprinted objects are imprinted on the next layer. So this is the solid modeling basically. So we came up with the 2D basic profile, which is a bigger rectangle for our soil model and smaller rectangle for our raft. Then you use the extrude commands to create the solids. We imprinted the building to the top surface of the raft to make sure that the load is properly transferred from the building whenever we activate it, and we also imprinted it on the bottom face of the raft so that we can create piles out of it. Let me show you how. What I'm doing is now I'm hiding everything except for the raft. Fine. So let me just try to hide this point as well. Okay. Now I can use extrude command. Till now what we were doing is we were selecting face and we were extruding it into solids. Similarly, you can extrude points. This point can be imported from DXF, or you can just give the point location. Like you can just come here and you know that where exactly your pile location is. You can give 2D as well as 3D coordinates to create that point. And then you come to extrude. Okay, now select the target object. I'm going to the bottom view. Please note that bottom view. So from here I am starting my piles. Okay. Now how to basically select the target object. I am first of all changing it by select by single or select by rectangle. Okay, and I'm changing this to point. So my target object are the points. Okay, so I'm selecting this part, which is now if I select like this, you will find that all are selected. Okay, so here GTS NX gives you a very easy option. Now first I'm saying unselect all, like front selection only. Okay, so front selection only. If you go and you can select this, okay, so you'll find only 44 objects selected. Okay, select the direction. So the direction is the vertical axis. Length is basically the length of pile minus 25. You can give it a name core piles. Okay, because this is where we will be expecting much of the loads coming and much of the settlement happening. Fine. Say apply. Fine. Similarly, now you can select the other, I can again make it point and select this points. Please remember that the front selection is on, so only whatever I'm selecting is in my view, nothing on the back hand side. Fine. So here I'm expecting less load, so I can go without any pile, or I can give it, let's suppose, minus 10 meters and give it geometry set, let's say outer piles. You can preview it, so check the direction and say OK. Fine. So already this, if you are making the pile other than the points which I have to create it, again you have to imprint this pile onto the raft. Same step, you have to go to imprint, go to curve, select the target object will be your base, and select the tool objects will be this curves to ensure proper nodal connectivity between the raft and the piles as well. Okay, as simple as that. But here we have just used the imprinted points to create the pile. So this is the basic modeling. Okay, so we have completed our modeling. Okay, so if I can show you what if I can revise what we did is we used two rectangles, the smaller rectangle to create the raft and the outer rectangle to create our soil profile using the extrude command. We imprinted basically the building which is in the DXF format exported from Gen onto the raft surface as well as the bottom surface. Okay, so the top basically was to ensure the nodal connectivity between the default mesh sheet, which is the building mesh sheet, and the mesh which we are going to create for the raft, and the bottom is basically we used it to extrude into piles. Okay, so after the geometric modeling is completed, so from the top menu bar you can move on to the next part, which is mesh. Okay, you have to define the material. Now these are the material which is basically imported from Gen. Okay, now I'm going to create a material for our soil layers and as well as for our uh, raft and section for our pile. So I'm going to isotropic. Okay, so in the model type you can select more column, give it a name, let's say layer 1. Okay, and I'm giving some values for the E value, 150,000 kilonewton per meter square, 0.320. In the porous tab, if you are dealing with any water level, so what is the saturated unit weight, the nonlinear cohesion and friction angle. So the requirement as per the more column material model. Say apply. Fine. Similarly, when you define, you can define for elastic. Okay, give it a name concrete. Define its E value, which can be for the raft. Okay, the Poisson's ratio and the unit weight. Say okay. So hope it is clear. So this is how you are going to define the material property. So this concrete can be same for the pile or and the raft, or can be different, it depends on you. Okay. So even if you have defined it earlier, so what I'm doing is I'm just undoing the two definitions. You can import it directly from already defined file. Okay, so just to save time, I'm importing the material property. I'll show you what exactly. Sorry. Okay, so I'm importing layer 1 concrete, layer 2, layer 1, and layer 4. Okay, similar definitions. I'm just saying new ID, say okay. Even I can delete this too, just to avoid copy. Okay, now if I can show you similarly for layer 2, modify, you have the same parameters defined, and similarly for layer 4 you have defined more column with all the parameters from the soil investigations. After you define that, you come to property. Okay, so these are the various sections imported for the building. Now you have to create property for your geotechnical modeling. So 1D, 2D, 3D. So we have 3D or the solid modeling for layer 1. So I'm selecting the material as layer 1 and just say apply. Similarly, select layer 2, create the property for it, say apply. Layer 3, layer 4, okay, say apply. And we have to use concrete, okay, because the raft is modeled. I'm giving it a name raft as a solid element, say okay. But you will agree with me that the pile has been modeled as a 1D element, so I'm going to 1D. So we'll model it as an embedded beam. Okay, material you can select any one. Okay, so I'm just using the same as used for raft. Okay, just for demonstration. And you can come to section, and let's suppose solid rectangle or solid round, whichever type of pile you want to model. Give it some dia, say okay, and the name as pile. Say okay. So first stage was geometric modeling, then you define the material and then the property. Okay. Next, you have to assign it to your surface, okay, or assign it to your solid, I mean solid and the curves. And it is the same time in GTS NX that you assign the material property or section to it. So it is at the time of meshing, you will assign the material to your model. So we come to mesh, 3D mesh. Let us start with the raft. Okay, so I'm just selecting the raft. I'm just giving it a size of 2 being the element size. Now very important part is now the raft, as you will agree to me, initially, okay, in geotechnical analysis, we try to keep the first stage as in situ or in-site condition to initialize the stress in the model because of the cell fade. Okay, so GTS NX provides you with the option to change the material of any solid or any 1D element or 2D element during the construction stage. Okay, so what will happen is initially I will mesh it with the property of layer 1. Okay, but I'm giving it a name of raft so that I can differentiate it from the other mesh set. Just say apply. Okay, so proper nodal connectivity will be ensured if I activate the raft and I just hide the property just to show you that whether the imprint has worked properly or not. Okay, so if I zoom in, so each of the column is sharing a node. Okay, so this is what this is why we imported the DXF file to make sure that proper nodal connectivity exists between the two. Then I'm selecting the outer soil. Okay, now please remember that the raft is having the property of soil right now. Okay, giving it a coarser size, let's say 6, give it a name layer 1, say apply, select the second one, say layer 2, say apply. So please remember that it is this point that you assign the material to your solids, layer 3, and finally you have layer 4. Say OK. Fine. So the meshing has been done for the solids. Now let us do the mesh. I'm just hiding all the mesh sheets. Now we have the curves activated, which are our piles. I'm using the same section for this model. Okay, so you can come to 1D mesh, select the object. So please note that only the piles are activated now. So select all. So we have in total like 75 piles. So number of divisions 10, the assigned property of pile, and you can give it a name, say pile. Just say OK. So the mesh has been created for the pile. So if you come to property and if you check the pile, you can see the section as well. Okay. So this is the stage where we have completed our meshing. Okay. So whatever you create till the meshing, everything goes into the model tab of the workstream window. Okay. Now after that, whatever you create, the boundary conditions or any load you want to define will come in the analysis part of the workstream window on the left hand side. Okay, at times if it gets close, you can come to tools and you can show height from here. Fine, so it's customizable what you want to see on the working window. After that, now basically most of our task is done, but we'll start after the meshing. You come to static slope analysis. First, let us define the boundary condition. So first boundary condition will be for the model, for the soil model. Okay. Now GTS NX provides you with the basic and advanced option where you can manually select the nodes and apply to define the boundary condition, or you can just come to auto, just give it a name, ground support, and say OK. The program will automatically generate the boundary conditions for your model. Okay. Now the second boundary condition in GTS NX, as I told you, during the construction stage, you can change the property of any mesh set. Please note that you can only assign one material to a particular mesh set. Okay. Only with the help of this option, we called it as in a boundary, we'll find option change property. You go to construction stage. Okay. Now I select my raft. Okay. And during my construction stage, I want the property to change to raft. Okay, so please remember that whenever I will activate this mesh set, means that the property will change from soil to concrete. Now why we need this and why all this complexities is because the first stage we try to initialize the stress condition of the soil. So if you want to ignore it, you can directly mesh with the property of soil, but I just want to show you the option that this is option available where during the course of your construction stage you can change the property. So raft and just say OK. Fine. So you will see you have the ground support and a boundary raft. So whenever you activate it, means that the property of that particular mesh sheet has changed to concrete. Fine. So in the loads, we have already defined the self weights, and we have dead load and live load of the building mesh sheets. So basically our modeling is completed. We started with geometry. Okay, we created rectangle, uses the extruded command to create our solid. We came to mesh, define the material property, and with the generate commands we assign the material to that. Then we come to static slope analysis, define the constraint and the change property for our model. Quick revisions of what we did. Okay. Now we have already our building loads, so no need to define anything else. Okay. Now we will see how to define the construction stage. Okay, now in the same model, if somebody wants to check that what is the effect of the piles and what if I only go with the raft, so you need not create two separate models. You can do the analysis in the same model. Okay, let me show you how. So you go to construction stage in the static slope analysis, say stage set. First, I'm just giving it a name, raft analysis. So in this case, I'm sorry, I forgot boundary conditions. Okay, now for the piles, if I go to model, I just hide. So one more boundary condition. We have to restrain the piles for RZ. Okay, so you come to constraint, you go to advance, select all. Okay, and RZ for the rotation in Z direction, and you can give it a name, pile constraint. See, okay. So three boundary conditions, one for the support conditions, second the change property, and third the pile restraint. I'm sorry for that. Okay, so stage set. So you give it a name, raft analysis. So we will do a nonlinear stress analysis, say add. Now select this and say define construction stage. Okay, now you can keep your model on the right hand side. So to see how exactly your definitions looks like. In the SO data, I like to keep it activate so that I can see simultaneously what I'm activating and if I miss something or not. Okay. So first stage, I'm giving it a name in situ, which is the inside condition to initialize the stress condition. So as you will agree with me, we will have the 4 layers of soil, even the raft. Now the name is raft, but please note that the material assigned to it till now is soil. Okay, so we can keep it activated like this. Then the ground support condition. Okay, now please remember that it's divided, the stage definition is divided into 3 parts. Set data, so whatever you create remains over here. Activated data, whichever you want to use in the analysis remains in activated data, and deactivated data, if you want to remove something, will go into the deactivated data. So the ground support condition and the self weight. That is why I kept the self weight out of the dead load. Okay, because otherwise I have to activate whole of my dead load. So with that comes along the live load and the dead load of the building. So the self weight I have just activated. Okay, once activated, it will, whatever mesh set you activate, automatically the load will be activated for that mesh set. So clear the displacement. What does this mean is we just want to initialize the stress condition in this model, and we don't want to see any displacement because of the self weight of the soil in the soil. Okay, this is only for this particular stage. Save it. Then go to new, and I'm saying activation of raft. So please note that we are not considering any pile in this case. So to activate the raft, the mesh set is already activated, but it is having the property of soil. So just drag and drop the boundary condition. So you can see even with the picture visualization of the same, so that the property has changed now. So activation of raft, save it, then new, and then we can say building load. Okay, so in the building load, default mesh set is representing our building. Okay, and the dead load and the live load is basically the load along with the building self weight. The self weight is already considered because we have already activated the self weight. So whichever mesh set you activate, or automatically the self weight of that will be considered. So save it. So this is basically a construction stage definition for uh, analysis with only raft. Okay, now in the same model, if somebody insists that, okay, I don't want to create another model, okay, now I want to see what is the effect of pile raft. So you just say pile raft, okay, say add. So instead you have the option of copy. You just select this and say copy. So this will help me save some time. I can select it and I can give it a name, pile raft. Okay, say modify. So I just say pile raft, define construction stage. Okay, first stage remains same over here, as you will agree with me. Okay, so all the soil, ground support, and but in the activation of raft, we will be having activation of pile raft. I'm just naming it accordingly. So I'll activate my pile. Okay, and also the constraint related to it. Raft is already activated because we are changing the property. Just save it. And the third step will be the same. Building load will come along with the building. So as simple as that. Okay, so once you do it, just close it. Now we have completed the set definition. Now you can directly come to analysis, come to general. Solution type will be construction stage. So first set will create for raft analysis, say raft analysis. In the analysis control, you can select the initial stage for stress analysis. This is to say that which is your first stage. So just say OK. Say apply. And then I will change the method to pile raft. And I can give it a name, pile raft analysis. In the analysis control, I will check the in situ one. So OK and OK. Okay, so this is basically the general workflow. Now you can say perform. Okay, so I've all and just say okay. I've already run the analysis for you. Okay, so let me just go to that model file. Okay, so this is what we have completed. Now let us talk about the results. Okay, so once the analysis done, you can come to the results tab. So one we have the raft and the other we have the CPRF or the pile raft foundation. Now let us come to the last stage. Okay, so when the loading is being applied, which is the building load TZ. Okay, I'm just saying undeformed shape. Okay, now this is the case when you have only raft. Okay, now to visualize it better, I can come to mesh set. I can hide and only activate the raft. So as expected, towards the center we have more displacement. Okay, if I can probe what is the maximum and minimum displacement, so maximum, minimum. Okay, so 69 millimeter is what we are getting at the center, almost center, where we have the core of the building. Okay, now even you can activate the building. Okay, so 69, and you can click between any columns. Okay, to check what is the differential settlement. So minus 67, minus 53, or towards the end, what is the value? So what is the difference you are getting as a result of that? If I activate all the mesh set, okay, now I'm just showing you the various visualization tool. I can go to ISO value surface. So I'm hiding the building so that we can focus much more. Okay, if I say lower part, so this is all the area which is having a settlement more than minus 34. So as I move it, you can see this is the area which is having a settlement more than minus 60 millimeter, and accordingly you can move it to see the contours. Okay, so this can help you determine where exactly the piles are needed. Okay, so you can just move it like this. So this is just a visual tool to understand the results. Fine. Now let us see the results after the pile has been activated. Okay, so I just click on that. So if I go to now, this is the CPRF when the building has been activated, TZ. Okay, now let us probe the values. So it was 69 and now it has reduced to minus 40 millimeter. Minus represents in the negative direction. Fine. So even now if you want to just check for the differential settlement whether you are getting your piles are effective to reduce the differential settlement. So minus 39 and minus 22, which was almost like 20 millimeter, more than 20 millimeter has been reduced. Okay, so similarly you can check for different points of the column nodes how much they are settling. Okay, similarly if you want to just cut, you can cut inside in between the section, and you can see the influence of the pile. Okay, so how exactly the displacement of it. If I go to results for TZ, and if I cut in between, so you can see it's very uniform, kind of a similar what we have for a raft. And when I just change it to pile-raft, how exactly my piles are helping in distributing the load, and so reduction in the settlement. Okay, so this is how basically you get the forces. Now even you want to get the beam element forces, so you'll get the beam element forces even in the building. Okay, but what we will be interested more is in the pile, so you can hide it, you can check for the piles what is the axial force, okay, for all the piles. Fine. Similarly, you can get how exactly what is the bending moment, what is the bending moment for the piles, and if you activate the building, you will get for the building as well. Okay, so this is the general workflow of solving any problem in GTS NX. So you can see how exactly it helps to consider the soil structure interaction. Now if you want to perform a dynamic analysis, you can see the actual response with the soil intact and the earthquake at the bedrock level, how exactly your building is going to simulate. Okay, so hope I was able to give you a good insight about the capabilities of the problem to deal with a pile-raft foundation for a soil structure interaction problem, and how exactly GTS NX provides you a 3D platform to solve a pile-raft foundation analysis. So that's all from my side. Thank you very much for all of you for taking time out for this webinar.